If you're a student or beginner trying to understand IT, information systems, or programming without the confusing jargon, welcome to LD Tech Lab. Make sure to subscribe, and let's break this topic down step by step.
Good day, everyone. Today, we are going to explore one of the most essential foundations of modern technology, which is Database Management Systems or DBMS, together with SQL. Every application you use today, from school systems to online shopping and banking, relies on databases. This session will guide you from the basic concepts all the way to practical SQL skills, so by the end of this discussion, you will not just understand databases, but you will also know how to use them in real-world scenarios. In this presentation, we will start by understanding what a DBMS is and the different types of databases. Then we will move into core concepts such as tables, keys, and relationships. After that, we will introduce Oracle Database and its tools, followed by SQL fundamentals and syntax rules. We will then go into hands-on SQL commands, apply them in real-world case scenarios, and finally discuss best practices, common mistakes, and additional resources to help you continue learning beyond this session. A database management system or DBMS is a software that allows users to store, organize, manage, and retrieve data efficiently. Instead of keeping data in scattered files, a DBMS structures the data in a way that makes it easy to access, update, and maintain. It ensures data consistency, security, and integrity, especially when multiple users are accessing the same database at the same time. In simple terms, a DBMS acts as the bridge between the user and the data. There are different types of databases designed for different purposes. Relational databases store data in tables and are the most commonly used. NoSQL databases handle unstructured or flexible data, often used in modern web applications. Hierarchical databases organize data in a tree-like structure, while network databases allow more complex relationships. Object-oriented databases store data as objects, similar to programming concepts, and cloud databases are hosted online for scalability and accessibility. Each type serves a specific need depending on the system requirements. Many people confuse DBMS with Excel, but they serve different purposes. Excel is ideal for small-scale data handling and simple analysis, but it becomes inefficient when dealing with large datasets or multiple users. A DBMS, on the other hand, is designed for complex systems. It supports relationships between data, ensures data integrity, provides security features, and allows multiple users to work simultaneously. In short, Excel is good for personal or small tasks, while DBMS is built for scalable and professional systems. In a database, data is organized into tables. A table consists of rows and columns, where each row is called a record and each column is called a field. For example, in a student table, each row represents one student, and the columns represent attributes such as student ID, name, and course. Understanding this structure is important because it forms the foundation of how data is stored and accessed in any database system. To uniquely identify each record in a table, we use a primary key. A primary key must be unique and cannot contain null values. On the other hand, a foreign key is used to link one table to another, creating relationships between data. For example, a student ID in one table can be used as a foreign key in another table to connect related information. These keys are essential for maintaining data integrity and building relational databases. There are three main types of relationships in databases. One-to-one means one record in a table is linked to only one record in another table. One-to-many means one record can be linked to multiple records, which is the most common type. Many-to-many means multiple records in one table are linked to multiple records in another, usually implemented using a junction table. Understanding relationships allows us to design databases that reflect real-world scenarios accurately. Normalization is the process of organizing data to reduce redundancy and improve data integrity. In first normal form, we remove repeating groups and ensure atomic values. In second normal form, we eliminate partial dependencies, and in third normal form, we remove transitive dependencies. BCNF is a more advanced level that further refines the structure. The goal of normalization is to create a clean, efficient, and logically structured database. One of the most powerful database systems used in the industry is Oracle Database. It is widely used in enterprise environments such as banking, government, and large-scale applications due to its reliability, security, and performance. Oracle database is designed to handle massive amounts of data and complex transactions, making it a top choice for mission-critical systems. Oracle provides several tools to interact with the database. SQL Plus is a command line interface, SQL Developer is a graphical tool for writing and managing queries, Apex is used for web application development, and Oracle Enterprise Manager is used for monitoring and administration. Behind the scenes, Oracle's architecture includes memory structures, background processes, and data files working together to efficiently process and store data. SQL, or Structured Query Language, is used to communicate with databases and is divided into different categories. Data Definition Language, or DDL, is used to define database structures. Data Manipulation Language, or DML, is used to manage data. Data Control Language, or DCL, controls access and permissions, and Transaction Control Language, or TCL, manages transactions. Understanding these categories helps you know which command to use depending on your task. When writing SQL, there are some important syntax rules to follow. SQL is not case-sensitive, but it is a good practice to capitalize keywords for readability. Each statement typically ends with a semicolon, and proper formatting makes your code easier to understand. Following consistent syntax practices helps prevent errors and improves code quality, especially when working on larger systems. The create table command is used to define a new table in the database. This is where you specify the table name, columns, data types, and constraints such as primary keys. It is the first step in building your database structure, and careful planning at this stage ensures that your database will be efficient and scalable. Once a table is created, we use the insert command to add data into it. Each insert statement adds a new record to the table. It is important to ensure that the values match the correct data types and order of columns. This step allows us to populate our database with actual data that can be used for queries and analysis. The select statement is used to retrieve data from a table. We can filter results using the where clause to display only specific records, and we can sort the output using order by. These commands are essential for extracting meaningful information from the database and are among the most frequently used SQL operations. The update command is used to modify existing records, while delete is used to remove records from a table. However, these commands must be used carefully. Without a where clause, they can affect all records in the table. That is why it is important to always double-check your queries before executing them. Join operations allow us to combine data from multiple tables based on related columns. This is where relational databases become powerful. By using joins such as inner join, left join, and right join, we can retrieve connected data and generate more meaningful results across different tables. Aggregate functions are used to perform calculations on multiple rows of data. Functions like count, sum, and avg help summarize data and are commonly used in reports and analytics. These functions allow us to gain insights and make decisions based on the data stored in the database. In this scenario, we design a student record system. We create tables for students and courses, establish relationships using foreign keys, and write queries to retrieve information such as enrolled students and their subjects. This demonstrates how databases are used in real academic systems. In this example, we build an online bookstore inventory system. We create tables for books, customers, and orders, then use joins and aggregate functions to track purchases and analyze sales. This shows how databases are applied in business environments to manage operations and generate insights. To become effective in database management, it is important to follow best practices. Use clear and meaningful names, normalize your data, and apply constraints properly. These practices help ensure that your database remains organized, efficient, and easy to maintain over time. There are common mistakes that beginners often make, such as forgetting the where clause, using poor naming conventions, and not normalizing data. Avoiding these mistakes will help you prevent data issues and improve the quality of your database systems. Different database systems like Oracle Database, MySQL, and PostgreSQL have their own strengths, but they all use SQL. In developing a database project, we follow a workflow that includes planning, designing, creating, testing, and maintaining the system to ensure its success. This slide serves as your quick reference guide for the most important SQL commands. Mastering these commands will allow you to perform most database operations efficiently and confidently. To continue improving your skills, you can explore platforms like Oracle Live SQL, W3 Schools, and SQL Zoo. These resources provide interactive lessons and exercises that will help you practice SQL in real time. To summarize, databases are a critical part of modern systems, and SQL is the key to interacting with them. By understanding the concepts, practicing regularly, and applying best practices, you are building a valuable skill that is highly in demand in the tech industry. Keep learning, keep practicing, and start building your own database systems.
If this video helped you understand the topic better, please like, subscribe to LD Tech Lab, and comment below what you want to learn next. Your questions help shape future lessons.